Hello everyone, and welcome to the second video tutorial on the National Guidance for Plastic Pollution Hotspotting and Shipping Action. In the last video, we focused on phase A, the first part, and we saw how to collect and model trade data by Polymer and collect production data and where to input it in the different tools. And now in this video, we're gonna move along. And this video is mainly gonna be focused on the interaction between the polymer dimension and the sector dimension, as well as the recycling of plastic in the country. So just a reminder for the legend, where you see the hands are the section in which actually action is needed from the user. All the others are more modeling steps. And then at the bottom, you can see the dimension in which we're working in. And finally, the color of the box is described here in the legend. So some are focusing on data collection, some are field data collection. So this is more online. Yeah, this is more field data, validation steps, calculation step, and mass balances. So we're gonna start with the step 3, and this is a validation step. So basically, we saw last time in tool T3.2, we collected data on import and export and production. And now the tool T3.2, which is, sorry, but as you see, is the only tool that we're gonna use in this module. We collected the data of import, export, and production by Polymer. And this created automatically if you go in the Polymer output file, a net input by Polymer classification. And this net input by Polymer is basically production plus import minus export. We call this net input. But then in order to go from the net input to the waste, we need to know how much of this plastic that is put on the market goes to add to the stock, because we're not only looking at items that we're gonna go to waste within the year, but we're looking also at items like plastic in cars or in construction, at many different, like all sorts of plastic that goes on the market. And so some of the object in which plastic is embedded are not gonna go to waste within the same year. And similarly, there are objects that were produced in earlier years that will go to waste this year. So for this reason, we need to know in which sector these different polymers are going. And for this, we use a polymer bisector matrix. So if you go in the polymer bisector matrix sheet on the tool, you can see that there is this matrix, share of polymer by sector. And basically it tells you, given a polymer, usually in which sector it's used in. So now step 1 is to kind of validate this matrix, and it's an optional step, and it just means that the matrices that we're using are global matrices. And here above you can see like different sources of literature that we use to compile the matrix. So these are global matrices that are valid kind of for the world plastic trade, but then it can be that in your country, you know, that there is some specific, use, for example, that PET, that somehow PET, instead of being using on 99% on packaging, is used, I don't know, a lot in agriculture. So you can go ahead and change the value there and change the share. Right. So this would be step 3. And step 4 is about calculating inputs by sector. So as I said, we have the net input by polymer, and now we use this matrix to then calculate the net input by sector. And from there, we can know in which sector the plastic is going. And so how to compute the waste generation by considering that some products are short-lived and some products are long-lived. So if you go to sector output, you're going to see that now we have some bars appearing, and these are for the different sectors. The bar represents the net input, and some of these are short-lived, like packaging, and some are long-lived. Now the next step is going to be to calculate the waste generation by sector, and this is done always in sector output sheet, but you need to go a bit farther down, and there is kind of a table over here, and here you see that it computed the waste for the different sectors. So it has the plastic input, which is what we see in the graph on top, and then from there it computed the waste. And for example, if you look at automotive, you see that the net input is much higher than the waste, and similarly construction, there are 1 million ton of waste of input in the market, but only 100 waste coming from previous year, because normally this happens when there is a lot of growth, and so it means that the waste coming from previous year is smaller. The number of cars that we're building in 2018 is higher than the number of cars that we built year backs because of the economical growth, and so there is an increase in stock, and the waste generation is smaller. So we mentioned it already quite a few times, but waste and stock go hand in hand, and step 6 is the calculation of the stock by sector. And maybe just to tell you a bit how this is done, if you go in sector input, you can see that there is a section that is stock and waste generation. And here it asks for the growth rate in percentage. And this is actually the industry added value, and the code computes this automatically. You see there is like formula there, and basically it takes the country here that we're giving as input, and then it goes in a backend sheet, this one, GDP growth, where we have GDP data, like industry value added for the World Bank, and it extracts the value for the desired country over here. So if there are no data, it's gonna go and look for GDP, which is just lower down here. This is GDP growth. And then once it compiles this vector of GDP growth from 1960 onwards, then it goes and copies it over here. So if you want, you can just have a look and see if it seems to make sense to you or not. And as we can see in Thailand, in Vietnam, there was quite a big growth in the industry sector in the last years, which also explains why we have a reduction in waste with respect to the input, because a lot of it is going to stock. So the stock, you can visualize it in the gray bar here. This is the stock, and you see packaging, there is no stock because all of the packaging waste goes to waste within the year, but like construction, as we mentioned, like a lot of it goes to stock. And the difference between the two, so this part kind of that is missing, is the waste, but it's not thrown because we're gonna actually refine better what happens to the waste. Like, does it go to recycling? Is it properly disposed? So we can now move on to step 7, which is collect data on recycling by Polymer. And here you see there is the hand. So far, all that we've seen is basically done automatically by the code. And now step 7, you actually need to put some input, and the input that are needed are recycling data by Polymer. So we go back to Polymer input, and you see that there is collective for recycling, formal, informal, waste trade, and domestic recycling. So there are these 3 boxes, and this is actually both step 7, collect data on recycling by Polymer, and step 8, collect data on waste trade by Polymer. So we're going to do the two of them together at once now. So basically, collected for recycling, formal, informal, the idea here is that depending on the country, either the recyclable waste is collected, together with the normal waste by, the waste crew that pass by, they collect all the waste, and then some of it is going to be sorted and go elsewhere. So kind of if you sort your waste at home and then you throw it in a bin and then the crew comes by and collects it, this would be formal collection of recyclable. And informal collection, it has more to do like with waste pickers that collect waste either on the street or a dump site. And here we just put some example of what we mean with formal and informal collection, because it's a term that we use, is a general term that we don't use to indicate whether the system is formalized or not. It has more to do with where would the recyclable waste go otherwise if it was not collected. So you can just read through this explanation if you want to have more information. But for the case of Vietnam, we're going to consider that most of the waste, the recyclable waste, is informally collected. So let's just back up a bit. We need to first start with the amount of waste that is collected for recycling. And here again, we need the value in 1,000 tons. And for this, you need to go and do some desktop research or maybe talk with local stakeholders. So we were lucky enough to have assessments that were already done. And so there was literature on the topic in the case of Vietnam, sorry. So I'm gonna go ahead and show you these documents. We're gonna start with these reports. So both reports were done by GA Circular and then sponsored by different partners. So this is the National Plastic Action Partnership baseline result for Vietnam. So it's also called like the NPAP report, supported by the World Economic Forum. And if we go down at page 103, right, you find average collection rate of recyclable by informal collectors in Ho Chi Minh City and Hanoi and Da Nang. And so it tells you on average how much waste is collected by the informal sector in terms of PET, HDPE, and other type of plastic. And this is the different kind of type of informal collectors that are out there. So I'm gonna take this one. This is kind of what I do when I find like a source. I copy paste and then I take the screenshot and I paste it over there. And then I reduce it and then I can put GA Circular and pop presentation. And then so this kind of tell us the split, but we don't know yet how much plastic is collected. And then there is another, let's say, a report that was produced by the same authors, but kind of, as you see, in a more like a report form. And if I go down to page 23, here you see it says the informal sectors collects a total of 322,000 tons. So I'm gonna copy paste this one, put it here, and then report. And so, right, so kind of combining these two pieces of information, we managed to build a picture of what happens in Vietnam. And this was actually also thanks to then talking to local stakeholders on our side. So it was not just these two reports, but I can give you the final values that we compiled, and it would be 137,000 tons for PET. And you see here there's error appearing because this checks that if you put a value there, then the sum of formal plus informal needs to be the same, but we're going to fix it later. So for the moment, I'm just going to write the total collected for recycling. So PET is 137, HDPE 73, PVC 20, LDPE is 34, other is 0, and then what am I missing? Polyester is 0, PP 45, PS 13, synthetic rubber 0. So we said that we're going to assume it's all informally collected, because this is the insight that we got from being there and talking to stakeholders. And now you see I get an okay over here because I just put that the informal collection is equal to the total collected for recycling and the formal collection is 0. And now you can scroll down and you see is now asking about the waste trade. So the waste trade is actually something that we looked already at when we worked with Comtrade Embassy. And if you see around here, but I will just tell you, the problem is that often a lot of it goes in the category other. As you see here, there's import of waste, export of waste, and a lot of it goes in the category other, but this doesn't mean actually other than this polymer. It just means some mixed type of waste or unsorted type of waste. So they don't know which polymer it is. So it's more like a category unknown. So we want to distribute. We're going to just assume that the total imported amount is correct and the total exported amount is correct. And then we're going to go ahead and define a split by polymer over here. So in order to do that, we need to know what happens to the polymer when it's imported. And it turns out that in the case of Vietnam, the imported waste is recycled by the formal sector. And there is a report on formal recycling in Vietnam by the Chamber of Commerce of Vietnam. So if I go back to my report, you can see this report by the VCCI, Vietnam Material Marketplace, and then I go to page 41, and you see there is this table, and there are the different name of the company, and it says whether it's a producer or a waste service. So we just take here they're talking both plastic and paper. So we're gonna look just at the plastic. And as you see around here, they started listing all the different recyclers for different type of polymer. So, I mean, I'm just gonna screenshot this to keep track of where it comes from. But basically what I did is that I extracted all of this value. I looked at the different polymer, and then I tried to assign this to the different polymers. And then we talked to local stakeholders and tried to make like a better allocation by polymer. But this is something just to show you how it could work. And I guess one important thing to mention is that it's always better, even for just the standard, recycling that we talked about before, it's always better to have values in tons rather than having rates, because the rates can be misleading if you actually take the rate maybe on what is collected rather than what the waste that is generated, because the waste that is generated, it's hard to know. It's much easier to know what is collected. But now this is what we're trying to do. We're estimating how much waste is generated, and then by knowing how many tons of it are recycling, then we can compute the recycling rate accurately. So I'm just gonna put BCCI, and then basically we combine this with, as I said, like conversation with local stakeholders, and eventually the values that I have are 46 for PET, 1 for PPC, 554 for LDPE, 0 for HDPE, 13 for PP, 1 for PS, 0, 0, 0. And maybe you'll notice that this sums to 615. And the import of waste was actually summing only to 322. Normally, I would say for the majority of the country, if you don't have better insight, you just use the value of import of waste that you have. In this case, for Vietnam, we had better knowledge, so we used this data that were provided to us in combination with the data from BCCI. So it is possible that the value that you have from Comtrade are not correct, but I would say that if you don't have any other insight, it's good to use them. And then in terms of export of waste, we're just going to assume that the waste that was collected for recycling, part of it is exported. So we're going to use, in this case, the value reported here. So I'm just going to sum to see how much it is, and it's 81,000 tons. And then I'm going to distribute it in the same way that the recycling is. So I'm assuming that of the recycling, of the waste collected for recycling, some of it is exported. And so the split by polymer, I assume that is going to match this one. One way to do this easily is to kind of copy here the share, so you can take the value and then divide by the sum. And then you drag it down. And just to check, if you selected all, you see it needs to sum to 1. And if you decide to put it in percentage, it needs to sum to 100% down here. And then we're going to take the value that we computed over there, and you need to put $sign if you want it to stay fixed. So we're going to take this value and multiply it by this. No? Yes. Yeah. Drag it down. And before doing that, make sure that the list of polymer is in the same order. One way to go around this problem of always checking like whether the list is in the right order and all is to use the VLOOKUP function. And it's used quite extensively in this tool, like over here, and in all of the formulas, we mostly use the VLOOKUP function, so that then you can change the way things are sorted without worrying about it too much. So maybe if you're interested, you can go and look that up. And finally, next step, the domestic recycling. So as you see here, the domestic recycling of collected for recycling is already computed. So it assumes that the waste that was collected for the recycling, part of it is exported and the rest is going to be domestically recycled. And here you can see kind of the formula does just that. It takes the collected for recycling and it removes the export. And here, instead, we need to decide how much of the imported waste is recycled. And because of what we said earlier, we assume that actually all of the imported waste is recycled. So let me just put this in, again, the right order. If we want to do this like that, and then I'm gonna say equal to, and I go here, and I take the import of waste, and I drag it down. And alternatively, again, I could have used the VLOOKUP function. And now we're basically done, because now we've looked at the recycling, the waste rate by polymer, and now what is left to do is to map from like this recycling by polymer to recycling by sector through the polymer to sector key. And that is going to calculate automatically the recycling rate by sector and the export by sector. So again, if you want, now the new table we're talking about is down here. It is polymer by sector based on the waste. And you can, again, have a look at this mapping and see if it makes sense for you or not. And if you know the packaging, or in the waste of PET, that's not how it's split, or the waste of PVC, there is more. If you have better insight, you can definitely go ahead and change this. Now the polymer output sheet has started to show the different recycling. So this is showing the import of waste and the domestic recycling of that waste imported. And similarly, this would be the export of waste. And here, now in the sector as well, you see the recycling is allocated by sector. So you see that most of it goes to the packaging. And this is actually something that you can change if you want, the way that the recycling is allocated from polymer to sector. You can go in sector input, and then you go down, and here you have an optional section, and you see there is recycling by sector. And here, if you want to manually assign the recycling, and so far we use the automatic allocation through the mapping, but if you want, you can say, yes, I want to do it automatically, I want to do it manually, and then you're gonna see there is an error appearing, because now you have to actually go in and change the value over here and make sure that the domestically recycled matches with what you had, the sum of it matches what you had in the polymer, and similarly for the export of waste. So for the time being, I'm gonna put no. And then there is other optional things that you can do. And here above, there is a legend that shows that the value in gray are optional, while the value in light green contain by default options. But we're maybe gonna look through some of them later on. And that's it for the second part of phase A. And in the next video, we're gonna move on to phase B and look more into the waste management.